Topic for the day, circles. We will be studying some properties of this topic. Initially these properties used to be there in standard 10th, but now they have been shifted recently to standard 9th. It's an easy topic, definitely. Even if you are an average at maths, you can definitely do this topic. Simple concepts and direct applications. Okay, so let us first see two concepts. We will solve one or two sums based on them and then go ahead. First concept. What you do is you first say draw a circle. Okay. With a compass. You can even try this experiment if you wish to. You draw a circle. Let AB be a chord of the circle. Now these terms you have studied in lower classes, interior of the circle, exterior of the circle, chord, tangent, secant. These terms you have studied in lower classes. So I am not revising on that part. We are straight away coming to the essence of the topic. Okay. So circle with center O. Let AB be the chord of the circle. Now what you do, from O you drop a perpendicular 90 degrees. You simply drop a perpendicular without bothering where it is going to come. Our target is, first we draw a circle with center O. Then we draw AB as our chord anywhere. You could draw it here also. It has been drawn here. Now from O, which is the center of the circle, you draw 90 degrees. You drop the perpendicular. Fine. So data is a circle with center O. A circle with center O. AB is a chord. AB is a chord and OM is perpendicular to AB. OM is perpendicular to AB. This is what is the initial setup. Now what is our conclusion? Out of curiosity, if you measure AM and if you measure MB, you will realize that they are equal. If you measure AM and if you measure MB, you will realize that they are equal. Now what we did, we never took M as the midpoint. We simply drew OM perpendicular to AB. Our intention was never to make AM and MB equal. However, it automatically turned out to be equal. So now this gives rise to a concept. Okay, and we say our conclusion is AM is equaling MB. This is our conclusion. So now how do we formulate this concept? How do we put it in the statement form? Keep this diagram in front of you and develop the statement. Perpendicular drawn from the center of the circle. That's important, not from anywhere. Perpendicular drawn from the center of the circle bisects the chord. Perpendicular drawn from the center of the circle bisects the chord. So I am writing here the concept. Concept 1, the opening concept of this topic. Perpendicular drawn from the center of the circle bisects the chord. You can even pause the video and take this down as your notes. So what's our data? Circle with center O, AB is a chord and OM is perpendicular to AB. This is what is known to us, initial setup. What is our conclusion? AM is equaling MB. And what is this concept called? Perpendicular drawn from the center of the circle always bisects the chord. Okay. But then that chord should not be the diameter, because if it is a diameter, then how would you draw the perpendicular on it? You know, because diameter is also a chord. In fact, it is the longest chord of a circle. So is concept 1 clear to you? So data is there, this is our conclusion, and this is the concept. Now in case I am not covering the proof of this concept, proof is also there in our syllabus. It can be easily proved by congruency. So should we take it? Okay, let's have a quick look. How do I prove AM is equaling MB? You join O to A, you join O to B. Okay, so OA is equaling OB, radii of same circle. OM is equaling OM, common segment. OM will come in this triangle, OM will come in that triangle also. And these two, so I'll just we'll take it quickly. OA is equaling OB, radii of same circle. OM comes in this triangle, OM comes in that triangle also. So OM is equaling OM, common side. This is 90, this is also 90. So by which test will the two triangles be congruent? By RHS test. It is not by SSA test. There is no test called SSA or ASS. No, there is no test as such. This is clear-cut case of RHS test of congruency, you are aware of. So by RHS test, the two triangles are congruent, and if two triangles are congruent, then naturally AM and MB will be equal. Corresponding sides of congruent triangles are equal. So we have even proved it that this is true. Fine. Now let us see the converse of this concept. Converse of this concept. So this is fine. I am erasing this now. Second concept. Now what you do? Draw a circle by compass. Okay, you can perform this experiment. Let the center be O. Okay, you can even perform this experiment, to get a clear picture. So draw a circle with center O. Let PQ be the chord. Let PQ be the chord. Now don't drop a perpendicular. No. PQ is the chord. Okay. O is the center of the circle. Now you take the midpoint. You take the midpoint of this chord. Say let the midpoint of this chord PQ. Okay. So we have control now. We have taken the midpoint. So a segment has got only one midpoint, unique midpoint, that has been taken as C. So then PC and CQ should be equal. Now O is the fixed point, C is the midpoint which we took it. What can we do with two fixed points at the most? We can just join them by scale. So I join O with C. Kindly note, I am not trying to have any control over the angle. O was the center of the circle from the beginning. PQ is a chord and we took the midpoint of PQ. Let C be the midpoint. So we took PC is equaling CQ in the beginning. So now C becomes fixed. O was fixed in the beginning only. We simply joined O and C without bothering about the angle. We simply joined O and C. Now, out of curiosity, you measure this angle with a protractor. OCP you measure or OCQ you measure. You will realize that this angle will now turn out to be 90. See, we had not put this as 90. We initial settings kya tha? PC is equaling CQ. We took C as the midpoint. O was fixed in the beginning at the time of drawing the circle. We simply joined O and C without bothering about the angle. And automatically this angle has now turned out to be 90 degrees. This is the second concept. So what is our data here? A circle with center O and PC is equaling CQ and PQ is a chord and PC is equaling CQ. What is our conclusion? Our conclusion is OC perpendicular to PQ. Even this can be proved, okay, easily, but I am not discussing the proof here. You join OP, join OQ, basically try and prove these two triangles congruent, which you can easily prove it by SSS test, yeah. And then say that if two triangles are congruent, these two angles will be equal, corresponding angles of congruent triangles. And then add both the angles, say let this angle be X and X, because now we proved them to be equal. Na? How? By SSS test, both the triangles we proved them equal. So OP is equaling OQ, radii of same circle, OC is equaling OC, common side, PC is equaling CQ, given right in the beginning. So by SSS test, the two triangles are congruent. So these two angles will be equal, A and A, add both of them, 2A is equaling 180, it's a straight line, so A will be 90. So this can be quickly proved by using the techniques of congruency, direct proof. A proof is there in the syllabus, it can come in the exam. So OC would be perpendicular to PQ. This is our conclusion and this was the data. Now how do we formulate this concept in words? See, there are two ways. You look at this diagram and try to formulate it. The line joining the center of the circle, and the midpoint of the chord. The line joining the center of the circle and the midpoint of the chord is at right angles to the chord. The line joining the center of the circle and the midpoint of the chord is at right angles to the chord. We can frame it like this, or you can say converse of the first concept. Now in exam you can't write first concept like that. So which was our first concept? Perpendicular drawn from the center of the circle bisects the chord. So we can write converse of that. So I would prefer writing that way. It will be easier for most of you to remember like that. So this will be converse of the previous concept. What was the previous concept? Converse of perpendicular drawn from the center of the circle bisects the chord. So it will be easier for most of you to remember this concept, perpendicular drawn from the center of the circle bisects the chord, and this is converse of it. So we just say converse of. So it's easier. So converse of perpendicular drawn from the center of the circle bisects the chord. So this is your second concept. Fine. Now we will see some two good numericals which are based on these concepts. Question 1. Now we will be doing one or two questions based on the two concepts which we just studied. In the given figure, O is the center of the circle, AB and CD are two chords, fine. OM is perpendicular to AB and ON is perpendicular to CD. That is given. So we have marked it. AB is 24, okay. OM is 5. OM is 5. ON is 12. What we need to find? Radius of the circle and length of chord CD. Okay. Now let's see how do we go about it. AB is 24. It's given. AB is 24. Now see, OM is already perpendicular to AB. So which concept will come, the first one or the second one? The first one, because perpendicular is already drawn. So remember, perpendicular drawn from the center of the circle bisects the chord. So this will be 12 and 12. So we'll have to write down here AM is equaling MB is equaling 24 upon 2, that is 12. Very important to here, I am not putting the reason because of the space constraint, but you will have to write down the reason. Perpendicular drawn from the center of the circle bisects the chord. And you have to show this calculation. Mark it in the diagram because that will lead you towards the unknown. This is done. Now what else can we say? This is 5, this is 12. Okay. We need to find the radius of the circle. So see, sufficient data is known this side, So we can join this. OA can be joined, OB can be joined, OC can be joined because you want to find the radius, right? So you can join OC, you can join OD, OA, OB, but right now I am joining OA because sufficient data is known this side. So it will be easier to find OA. Now observe this triangle OMA. OM is 5, this is 12, we just now worked it out with the reason. So can't we find OA by Pythagoras theorem? So we will have OA square is equaling 5 square plus 12 square. That works out to be how much? 25 plus 144, 169. The reason would be Pythagoras theorem. So OA would be square root of 169, that is 13. So now OA has worked out to be 13. So radius of the circle, we can just double underline this answer. So 13 in the bracket, we can just write radius, indicating that first subpart is now done. Now what is remaining? Length of chord CD. CD we want length. And what data do we have on this side? Only this. ON is 12. With this, can we directly find CD? No. So what we do? We join OC. Once you join OC, how much would be OC? 13. Because OC is also the radius of the same circle, right? OC is the radius, OA is the radius. So if OA is 13, OC also will be 13. OC is equaling OA is equaling 13. What would be the reason here? Radii of same circle. Radius is singular, radii is plural, RADII. Radii of same circle. So this is now done. So now the problem is almost done. This is 13, this is 12. We will find CN. How? Pythagoras theorem. See, in these cases, distance formula, these theorems what we just taught you, Pythagoras theorem, all will come mixed. So Cn square is equaling 13 square minus 12 square, which is 169 minus 144, which is 25. That is Cn square. So Cn will be square root of 25, that is 5. So Cn is now 5. But the problem is not yet over. We need length of chord CD. So now if Cn is 5, CD will be naturally double of it, that is 10. What is the concept we are using? The first one. Perpendicular drawn from the center of the circle always bisects the chord. Bisects means it divides the chord into two equal parts. So if this is 5, this ND also will be 5 because this is center of the circle. This is the perpendicular, and perpendicular drawn from the center of the circle bisects the chord. So here I will put it. We will have to write CD is equaling 2 into Cn. That is 2 into 5, that is 10. Centimeters, yeah. No, here units are not given. So we will just write 10. It's fine, no problem. So if Cn is 5, CD will be 10. What is the reason? But reason you will have to write perpendicular drawn from the center of the circle bisects the chord. Now since you had written that reason in the very first step, it is okay if you do not write it here, because the same reason repeats itself more than once in the same sum. It's okay if you write it at one of the places. In case if that reason does not strike you, you can still find CD by a little longer way. You will have to join OD. Okay, you will have to join OD. OD will be how much? 5. Because OM is, OD will be 13. Because OA is the radius, OD also is the radius. So OD would be 13. This is 12. Then you can find ND by Pythagoras theorem, the way you did for CN. Find again ND by Pythagoras theorem. Okay, after joining OD, you will get ND as 5, and then CD will be 5 plus 5, that is 10. That is also okay, but that would take a little more time. This would be better, right? So we have finished finding the radius of the circle. We have also finished finding the length of the chord CD. This completes with your problem number 1. Okay, now question 2. The given figure shows a circle with center O. Diameter AB bisects the chord CD at E. Diameter AB bisects the chord CD at E. Bisects means divides into two equal parts. So CE will equal ED. CE is 8. Okay. CE is 8 and EB is 4. This much is 4. Find the radius of the circle. So radius would be what? OD or OC or OA, whatever convenient to find. All of them are radii of the same circle. Fine. This is the only information and we need to calculate the radius. So we will join OD. Okay. We will join OD. Now we know this is 4. And mind you, this DE is same as EC. It is given there. Diameter AB bisects the chord CD at E. So you should know the meaning of the word bisects. So CE and ED will be equal because the diameter is bisecting the chord. Now this is given as 8. So this also will be 8. DE also will be 8 as EC is given as 8. Now what is our target? Our target is to find the radius of the circle. That is OD or OC or OA. Fine. But we will work on this side because a lot of information is known. Now, how do we find OD? See, this OE is not known. No angle is given. If there was 90-degree angle, then we could have used Pythagoras theorem in triangle OED. That would have been easier. But this angle is not given 90. At this point of time, some idea strikes your mind. This is the center of the circle. E is the midpoint of CD. E is the midpoint of CD. So angle OED is bound to be 90. Concept number 2 which we studied. First one was perpendicular drawn from the center of a circle bisects the chord. And then we studied its converse. That if you take the center of the circle and if you take the midpoint of the chord and if you join it, then that angle is going to be 90. So here first concept is not used, second concept is used, the converse of the first concept. So we will now have to work out like this. We will have to say, we can say like this, OE perpendicular to CD. OE perpendicular to CD. What reason we will give? Converse of perpendicular drawn from the center of the circle bisects the chord. See, first time when you are doing this topic, you can very much keep the concepts open in front of you. So you will be able to, correlate better and things will go easy. Okay, so OA is perpendicular. So now I will mark this angle as 90. So we can apply some Pythagoras theorem, but how? What has happened? This is E now. How do we apply Pythagoras theorem in triangle DO? This is O. If you want, I will write here a little closer for better understanding. We can apply Pythagoras theorem to triangle DOE and find, but how? This is given as 4. This is going outside. Okay, so what we do? You take this OE as X. Instead of keeping it OE, you take it as X. Now, how much will be OD? Just observe. What is OD? The radius. What is OB? Again the radius. OE right now we took it as X. This was given to be 4 here. So how much is OB now? X plus 4. How much is OD? X plus 4, radii of same circle. So now we are coming closer and closer to our solution. OD will be same as OB, that is X plus 4. You can give the reason, radii of same circle. So now this works out to be X plus 4. I repeat, OD is same as OB. OB is X plus 4. So OD also will be X plus 4. Now it is trivial. Apply Pythagoras theorem to triangle OED. Who will act as the hypotenuse? OD, because hypotenuse is a side opposite to 90 degrees. So this is in my 90 degrees. So OD will act as the hypotenuse. So now we will have OE square plus OE square plus DE square is equaling OD square. OE square plus DE square is equaling the hypotenuse square. That is OD square. The reason you can write Pythagoras theorem. Now substitute. OE is X, so X square. DE, where is DE? DE is how much? 8. So 8 square is equaling OD square. OD is X plus 4 because of the reasons explained earlier. Now it is simple substitution. Solve for X. So X square plus 64 is X square plus 16 plus 8X. This will get cancelled. 16 will come here. So I will just squeeze in the solution here. Okay. 64 minus 16 is equaling 8x. So 64 minus 16, how much? Oh, let me work out. This is 8, 48. Correct, no? So 48 is equaling 8x. So x will be 48 upon 8. That is 6. But just because we have found x does not mean that the answer is over. We have worked out x. What is required? Find the radius of the circle. What is the radius of the circle? OD or OB, whatever. So if I take OD as my radius of the circle, which it is, x is 6. So always revisit the question and see. Just because you have worked out so many things does not mean that you have reached the final thing. So x is 6 here. So ultimately radius is OD, that is x plus 4, that is 10. So radius of the circle has been found out to be as 10 centimeter. Final answer, better you write down the units. Intermediate steps, no need to write down the units. Sheer waste of time. Units to be written only in the final answer. So OD is 10 centimeter, and this completes with your question number 2, right? In case they ask you find the diameter, then diameter will be twice of radius, that will be 20. But anyway, diameter is not asked here, but in case. So comfortable with this sum? Fine. Now we saw 2 concepts and we solved two numericals based on it. Now we go ahead with the concept. Concept number 3. circle, two chords AB and CD. Two chords AB and CD, but the speciality is that AB and CD here are to be taken equal. So equal chords. I reiterate, AB and CD are two equal chords. So if AB is say 7 centimeter, CD is also 7 centimeter. Now if someone asks you how far is AB from the center of the circle? How far is AB from the center of the circle? So then what kind of distance would we take? We cannot take this slanting distance. We will have to take the perpendicular distance. We will have to take the perpendicular distance. So AB and CD are two chords. How far is AB from the center of the circle? So we will have to say this much away. So we will have to say AB is at a distance of OM. Okay, from the center of the circle. O is to be taken as a center. How far is the chord CD from the center O? How far is the chord CD from the center O? So let this be N. So chord CD is at a distance of ON from the center of the circle, the perpendicular distance. Now the concept says, if chord AB is equal to chord CD, then OM also will equal ON. If chord AB is equal to chord CD, then OM will also equal ON. So how do we frame this concept? Equal chords are equidistant from the center. So this is the way we will write. Equal chords are equidistant from the center of the circle. So what is our data? Our data was chord AB equal to chord CD, and O is the center of the circle, and OM is perpendicular to AB and ON is perpendicular to CD. So these two are equal chords. Our conclusion will be, what will be our conclusion? That OM is equaling ON. Okay, so equal chords are equidistant from the center. Now based on this, we will cover a quick numerical here only, not specially. Suppose if a question is framed, chord AB and chord CD are equal, but what are its measurement we don't know, but they are equal. O is given to be the center of the circle, and we are told that OM is 2.5 centimeter. Okay? OM is 2.5 centimeter. Find ON. Find ON. What will be our answer? No need to join OA and all that, nothing. Directly we will say OM is 2.5. Therefore, ON also will be 2.5. And of course, the reason has to be given. Equal chords are equidistant from the center. So there was a quick numerical based on this. So are you clear with the concept and the numerical based on it? Now we will see concept number 4, which is the converse of this concept. See how we had concept 1 and concept 2 was the converse of it. Similarly, concept 3 is this: equal chords are equidistant from the center. Now concept 4 will be the converse of this. here what is the data? A circle with center O. There are two chords AB and PQ. Nothing is given if they are equal or not, nothing. Straight away, simple. AB and PQ are two chords. A circle with center O. How far will be chord AB from the center of the circle? How far will the chord AB be from the center of the circle? Perpendicular distance OM. And how far will the chord PQ be from the center of the circle? Perpendicular distance again. We can't go on taking slanting distances, no? Because they keep changing. Okay, so ON. And it is given OM is equaling ON. Now it is given to you that OM is equaling ON. So what can we infer? Chord AB will definitely equal chord PQ. So this is converse of the previous concept. So here what is our data? Let's understand what is given and what is our conclusion. Here we have OM is equaling ON is given to us. OM is perpendicular to AB. That's important because whenever we are seeing the distance of a segment from the center, whenever we wish to understand the distance of a segment from the center, from any point, we always take perpendicular distance. So OM is equaling ON, OM is perpendicular to AB, and ON is perpendicular to PQ. Of course, O is the center of the circle, that is also given. Okay, what will be our conclusion? Our conclusion will be chord AB is equaling chord PQ. So have you realized this is the converse of the previous concept? Now how do we frame it? See, we can say that if two chords are equidistant from the center, pehle sahi, if two chords are equidistant from the center of the circle, then they will be equal. This is what we can formulate concept number 4. But if you find this difficult, then what you do, you learn concept number 3 and just write converse of that. So we will write that way. Converse of the previous concept. What was the previous concept? Equal chords are equidistant from the center. ये उसका उल्टा है, converse. So converse of equal chords are equidistant from the center. So please do not confuse between concept number 3 and its converse. This is the converse. Here we already know that the chords are equidistant. So chord AB and chord PQ will be equal. So a small numerical which we can have on this will be, say, OM is 3 centimeter, ON is also 3 centimeter. What is the relation between chord AB and chord PQ? So we will say chord AB and chord PQ will be equal, and we will have to cite this reason. Fine. So this completes with concept 3 and 4 also, and there was a quick numerical based on it that also has been covered. Concept 5. A circle with center O. So you say you have OA, OB and say OC. Fine. Here we will fuse certain concepts. It is easier and better to learn like that. You have this arc AB, not segment AB, arc AB. So if you want, we can put some letter here. So arc APB, and you can say arc BQC. So you don't confuse between chord AB and arc AB. O is the center of the circle. What the concept says, if arc AB, or I would say now rather arc APB, this arc, clear to you? If arc APB is equal to arc BQC, if arc APB is equaling arc BQC, if the lengths of these arcs are same, then they will cut equal chords as well. So chord would be AB and another chord would be BC. The concept says if arc APB is equaling arc BQC, if arc APB is equaling arc BQC, then chord AB will equal chord BC. Don't confuse between arc APB being equal to chord AB, that is not possible. Chord AB will be naturally shorter than the arc because arc is curved and chord AB is a straight line distance. What it tries to say, if arc APB is equaling arc BQC, then chord AB will equal chord BC. Comfortable with this? So this is one concept. We will fuse this with something else now. Now we will say if chord AB is equaling chord BC, then angle AOB will equal angle BOC. Note this carefully, how we have fused the concepts. First one, if arc APB is equaling arc BQC, then chord AB will equal chord BC. Further extension, now if chord AB and chord BC are same, then they will subtend equal angles at the center also. Subtend means form. So this is chord AB, it will subtend an angle like this. So this is X. The chord BC will subtend an angle, form at the center. So these two angles also will be equal. Fine with this. So we repeat, if arc APB is equaling arc BQC, then chord AB and chord BC are equal. Extension, if chord AB and chord BC are equal, then they will subtend equal angles at the center as well. Now we can connect this arc directly with the angle also. We can say that if arc APB is equaling arc BQC, then the angle at the center subtended formed also will be equal. So how do we frame it now? How do we formulate the concept and formally write it down? We will have to say for this concept we will have to say equal arcs subtend equal chords. See, once you get the concept, you can formulate it. Equal arcs subtend equal chords. And how do we formulate the concept for this one? Equal chords subtend equal angles at the center. Subtend. This means forms. So for this one, how do we frame it? Equal arcs subtend equal chords. For this one, how do we frame it? Equal chords subtend equal angles at the center. And the last one, which can be fused together, we can also say equal arcs subtend equal angles at the center. Fine. So this takes care of your concept 5 and you can mix and use this. We can also use the converse of it. If the angles at the center are equal, then they would form equal arcs. Reverse is also true. Converse is also true. So if two angles at the center are equal, then they would subtend, like this is the angle, then they would subtend equal arcs if these two angles are equal. So that would be the converse of it. So a quick numerical on this can be like this. They would say arc AB and arc BC are equal. Arc AB and arc BC are equal. Chord AB is 4 centimeter. Find length of chord BC. No calculations. Directly you will have to say chord BC also will be 4 centimeters because arcs are equal. So chords also will be equal. Do not confuse between the arc being equal to the chord. That is not possible. Then they can further say, if this angle is 23 degrees, find this angle. So we will have to say this angle also will be 23 degrees, and we will have to cite the reason. Equal arcs subtend equal angles at the center. So if this is 23, this also will be 23. If they ask you angle AOC, fine, 23 plus 23, that is 46. So are you clear with these concepts and the quick numerical which we had on it? Now this completes your topic of circles, all properties explained and some numericals done. Thank you so much.